So we have an interesting puzzle, a very logical puzzle. Let's try to read the questions and let's try to see if we can solve it. There were 35 logical friends who were trying to get tickets for a session held by a famous mathematician, Mr. X. But Mr. X put in a challenge for all the 35 of the friends to get into the session. He gave a cap to each of the 35 friends, the color of which could not be seen by the person wearing it. However, a person was able to see the color of all the 34 caps worn by the remaining 34 friends. Given below are some of the rules put by Mr. X for the 35 friends. So basically what is happening is like 35 friends were given 35 different caps, different or identical, we do not know, 35 caps. And they should guess the color of the caps that they are wearing, only then they will be allowed to enter into it. But can I look at my own cap? No. But can I look at all the other 34 caps? Yes. That's how it is. Now, what are the rules? A person is allowed to enter into the session if he or she can tell his or her own cap color. Mr. X gives 1 minute time for them to think, at the end of which he opens the door. He repeats the process till everyone gets in. No person is allowed to speak anything until he gets inside the session. Okay, you are not allowed to speak, discuss, no signal, nothing. The friends do not know the total varieties of colors of caps. This is another tougher logic. What are they trying to say? You don't even know whether there are like 5 different colors or 10 different colors or 7 different colors. Nothing. The caps are distributed in such a way that it will eventually be possible for everyone to logically deduce their cap color, and everyone is aware of it. And this is the most important point of this particular set. The caps are distributed in such a way that it is possible for everyone to logically identify their cap color, and everyone is aware of it. So this is an important point using which we are going to solve the set. All the 35 friends played the game perfectly and gained their entry eventually in multiple rounds. The following events took place at the end of every minute. Okay, before entering into this particular problem, let's try to see what happens if there are there's a particular scenario. Let's say if I say there is only one guy wearing color 1. All the 34, let's say there is one person 1 who is wearing blue, and person 2 to person 35 nobody is wearing blue. Now if that situation is there, then you know what will happen? This person will look at random colors and he will have absolutely no idea that there is a blue color in this particular mix and that blue color he is wearing. So let's say there is only one person wearing a blue color cap and nobody else wears a blue color cap. For example, he will never be able to guess that he is wearing a blue color cap. In which case, this person will never ever get an entry into the session. I'll repeat this logic again. If a person is wearing only a single colored cap, as in like nobody else is wearing his colored cap, just by looking at the 34 other people's cap, they will be wearing maybe red, brown, orange, all those things. How can he even guess that his cap is blue color? He will never be able to do it. And therefore, this person will never be able to enter into the session. And what is the question saying? The question is saying that the caps are distributed in such a way that it is possible for everyone to enter into the session. Therefore, a person wearing the only color available there is not at all possible, which means a cap with a particular color given to only one person is a scenario that is not at all possible. So what is not possible? Say for example, person 1 getting black, person 2 to person 10 getting blue, person 11 to person 35 getting orange. Is this scenario possible? Absolutely not possible. Why is this scenario absolutely not possible? Because this guy will look at only blue colors and orange colors. There is no way that he will be able to deduce that he is wearing a black color cap or red color cap or even blue color cap or orange color cap. So a single person wearing the only color is not at all possible. Here multiple people are wearing it, that is allowed. But only one person is wearing this one particular color scenario is not possible, in which case it will be impossible for somebody to find their own color. Therefore, that is not possible. And this is the clue that we are going to get. For example, person 1, person 2 wearing blue, person 3 to person 20 wearing black, person 21 to person 35 wearing orange. Is this scenario possible? Absolutely possible. Absolutely possible, because this is a multiple cap scenario, multiple cap scenario, multiple cap scenario. What is not possible is, let's say, this is not possible, because this guy will look at black and orange only, and there is no way he can identify logically, especially without external clues, that he is wearing some color called blue. For all we know, he could have worn yellow. There is no way he can find it out, etc., etc. So this is the clue. A single color, there is no scenario where only one person is wearing that particular color. Okay, so which means every color is given to multiple people. This is the clue. Now, let's say there are caps which are having double wearance. For example, let's say person 1 and person 2 are wearing, let's say, green color cap. Person 3 and person 4 are wearing blue color cap. Person 5 and person 6 are wearing orange color cap. Person 7, person 8, person 9 is wearing, let's say, red color cap. Person 10 and person 11 and person 12 is wearing, let's say, pink color cap. And let's say all the other persons, person 13 to person 35 is wearing, let's say, violet color cap. Now let's say this is the scenario. Now let's think from each and every individual person's point of view. Now when you look at person 1, what is he observing? He is observing that there are many reds, many pink, many violet, many orange, many blue. But do you also observe that he is seeing only one green color cap? And because all these people are logical friends, 35 logical friends, these people will be able to deduce logically that a single color cap is not possible. But person 1 is seeing that only one person is wearing green color cap, which is a not possible scenario. Therefore, the green color cap has to be with some other person, and the only person that is possible which he is not able to see is his own cap. Therefore, person 1, when he sees that there is only one green cap visible to his eyes, he can easily deduce that that is not possible. Therefore, there must be a hidden second cap which he is wearing. And going by the same logic, the person 2 also, what does person 2 see? When person 2, when he looks at it, he is seeing one green color cap, multiple blue, multiple orange, multiple red, multiple pink, multiple violet, etc. So, person 2 will also be able to identify that, oh, there are multiple blue, orange, red, pink, violet, but there is only one green color. And we know that one green cap scenario is not possible, because that's an impossible scenario, and question says that it is possible for everybody to deduce. Therefore, person 1 cannot be the only person wearing green. There has to be somebody else that I am not able to see. And who else it is? Person 2 only. He himself only. Therefore, person 1 and person 2 will be able to identify instantly that they are wearing green color caps. Similarly, when you look at blue color, person 3 and person 4 also, person 3 will look at, hey, the only blue color cap that I am seeing is person 4. No, there is no other blue color cap, which means I am wearing blue color cap. And by the same logic, person 4 also will be able to see only one blue color cap. And if I am seeing only one blue color cap, then I can definitely deduce that I am the other blue color cap. So person 4 can identify his color, person 5 and person 6 can identify orange. So the double color scenarios can be identified in the first round itself. So in all the first round, the double colored caps can be identified. Double colored caps can be identified. What about triple colored caps? For example, if there are 3 people wearing red color, will they be able to identify in the first round? No. Let's go and see why they will not be able to identify. Let's look at this from a person 7's point of view. From person 7's point of view, he is seeing that these people are wearing 2 greens, these people are wearing 2 blue, these people are wearing 2 oranges, these people are wearing 2 red, multiple pink, multiple violet. So, for him, there are 2 reds, 2 green, 2 blue, 2 oranges. Therefore, he will not be able to tell. He could have had green, he could have had blue, he could have had orange, he could have had red. There is no way he will identify. He will not know. He will look at people and then he will say that, oh, I could have had green, I could have had blue, I could have had even pink or violet or anything. He can have any color, because for him everybody else's color is, this is double green, double blue, double orange, and multiple pink, multiple violet, double red. That is what is visible to him. So he is not able to single out saying that, oh, only one color is possible, one color is available, which is an impossible scenario, therefore I am wearing that other color, is something that person 7 cannot tell. Therefore, in the first round, all the double colored caps will go away. Now, all the double colored caps people will go away in the first round. And now, let's think from person 7's point of view. Now, person 7's point of view, because he's a logical person, he is aware that all the double colored people would have gone in the first round. Now, when he looks at pink color, you can see, he will see 3 pink, multiple violet, etc. But in red, there are only 2 red color people, 2 people wearing red color cap. And person 7 being a logical person will be able to understand that, hey, all the double colored caps should have gone out in the first round itself. Why are these 2 double colored caps not going out even after the first round? Maybe because they are not double colored cap, maybe it's a triple colored cap, which means there is a third person wearing the red color cap that I am not able to see, and therefore that third person is me only. So now person 7 will be able to identify that he is wearing the red color cap. Similarly, person 8, from person's 8 point of view also, if you look at person 8's point of view, what he will think? He will think that, okay, there are double colored caps, triple colored caps, quadruple colored caps, 5 colored caps, etc., etc. And after the first round, all the double colored caps people would have identified their caps and they would have gone out. And person 8 is looking at 1 red color cap and 1 red color cap. Why is there are 2 red color caps visible to me? If it is double colored cap, they should have gone out in the first round itself. No, they are not going out in the first round. Therefore, this is not a double colored cap. It has to be a triple colored cap. And the third person wearing it, which I am not able to see, has to be me only. So that logic person 8 would have identified, and person 9 also would have identified by the same logic. Therefore, when it is opening for the second time, who would have gone out? All the triple colored caps would have gone out, right? So the same logic goes with for pink also. Wherever there is a triple colored person, they would have gone. So person 10 will see only double colored caps. Double colored caps is, 2 people wearing pink, which is not possible because they would have gone out in the first round. So in second round, if they are there, then this is not double, it's actually a triple, which I am not able to see. The third person is me only. So that way, all the people who are having all the triplets would have gone out in the third round. So triple colored caps would have gone out in the second round. Now what will happen in the next round? In the next round, let's say for example, there is let's say person 10 person, okay, there are 1 2 3 4 people wearing same colored cap. Let's call this as, let's say, violet colored cap. Let's say 4 people wearing same colored cap. Now in this person's perspective, he knows that in the first round double colored caps are gone, in second round triple colored caps are gone. So there should not be any double colored or triple colored caps. That is what this guy will know, because he is a logical person, he will know it. But to his eyes, he is seeing 3 people wearing violet, which is not possible because all the triple colored caps would have gone out in the second round itself. Therefore, when he sees there are 3 people wearing triple colored caps, it is not possible that there are 3 people. There has to be a 4th person which he is not able to see. Therefore, in the next round, all the four colored caps and all will be gone. In the next round, 5 colored caps will be gone. And in the next round, 6 colored caps will be gone. This is the logic that we need to solve this problem. Now that we understand this particular logic, let's enter into the question. Once I enter into the question, what do we have here? 6 of the friends gained entry in after the first time gate was opened. So person 1, person 2, let's say we'll call them as they are wearing color 1 cap. then person 3, person 4, because all the double colored caps would have gone. So person 3, person 4, they are wearing, let's say, color 2 would have got an entry, and person 5 and person 6, they would have had a color 3 cap. So all these people would have gone out in first round there. Perfect. The friends wearing blue and green caps were entered the gate when it was opened for the second time. So when it was opened for the second time, person 7, person 8, person 9, these people, maybe they were wearing blue colored cap, and person 10, person 11, person 12, they were wearing green colored cap. So these people went in the second round. Perfect. 4 persons entered the gate when it was opened for the third time. So, which means person 13, person 14, person 15, person 16, only one set of 4 colored caps went. So, this may be some color 4, some unknown color 4, let's call it as. So, these are the people who went into the session during the third round. No one could enter the gate when it was opened for the fifth time, which means 5 colored caps nobody was having. So, there is no color which is given to 5 set of people. So 5 set people, there is nobody there, which is why during the fourth round nobody was able to enter. Now friends wearing multiple color caps entered the gate when it was opened for the fifth time. So when it was opened for the fifth time, we now know that 5 people would go as set. So till now how many people have gone? Till now we know that 16 people have gone out of 35 people. And how many is pending for us? 35 minus 16, 19 people are pending for us. So in this fifth round, okay, basically in the fourth round 5 people would have gone. In the fifth round 6 people would have gone. Did I say 5? Okay, pardon me. In the fifth round 6 people would have gone. In the let me repeat it again. In the first round 2 people would have gone. In the second round 3 people. In the third round 4 people. In the fourth round 5 people would have gone, but nobody was there. In fifth round 6 people would have gone. So 6 people, Adina, what it means is, let's say if and they are telling multiple color, which means not just one set of 6, 2 set of 6 or 3 set of 6 people have gone. If 3 set of 6 people have gone, then out of the remaining 19 people, so 16 people have come, right? Total out of 35, 16 people have come, remaining 19 were there, and 18 people were gone, Abdina. Then what will happen is only one person will be pending, which is not possible. Therefore, it is not 6, it has to be 6. So 2 sets of 6 people have gone here, and now how many people are pending? Out of 16, 16 have gone before this. 16 plus 6, 22, 22 plus 6, 28 people have gone till now, and now out up to 35 we only have 7 people pending. So 7th person, the 7 people would have gone in the next round, which is the 6th round. So basically, let's enter into the questions. How many different colors of the caps were given to the 35 friends? In the first round, they had 3 colored caps. In the second round, there are 2 colored caps. And in the third round, there was one other color. In this round, there were no other color. In this round, there were 2 colors. And in this round, there was one other color. So totally 1, 2, 3, 4, 5, 6, 7, 8, 9. So the answer for this question must be 9. After how many minimum gate openings were all the 35 friends be able to enter into the session? After 6 rounds. So the answer to this question must be 6. How many groups with the same color of caps went inside when the gate was opened for the 5th time? When it was opened for the 5th time, 2 sets of 6 people entered. So how many groups with the same colored? There were 2 groups of people. So 2 groups of people went. How many groups is what they are asking. So 2 groups went. Now, had there been 37 friends initially instead of 35, and all the rules and events remained the same as stated, then what would be the minimum number of time the gate was opened by Mr. X to ensure that everybody went in? Okay, so let's kind of replicate. Almost everything else is same here. Let me bring it here. Okay, so there were totally 35 people, out of which, let's say, until this third round everything else is same. Now after this we know that in fourth round nobody went, so there is no people with multiple, I mean 5 types of caps. Okay, got it. Then in fifth round there are multiple 6 peoples, right? Now it's not 35 people, the total are 37. Now out of 16, out of 37, 16 have gone, so remaining 21 is what is pending. Now if 21 people are pending to be gone, and here I can leave 6 plus 6 plus 6. So if I let 6 plus 6 plus 6, 18 people go here. For remaining 3 people, I will not have subsequent rounds, because all the subsequent rounds there will be more number of similar caps, 7 similar caps, 8 similar caps, etc. 3 similar caps is not possible. Therefore, what I can say here is there will be 2 people with 6 caps, and if 12 people are gone here out of 21, there will be remaining 9 people. And now in the 6th round, 7 people groups, nobody is there, they will not go. In the 7th round, 8 people group, nobody is there, so nobody will go. Only in the 8th round, 9 people group, the final set of 9 people will end up going. So fourth question, had there been 37 friends initially instead of 35 and all the rules remained same, then what would be the minimum number of times the gate was opened to ensure that everybody went in? 8 rounds. Had there been 37 friends initially instead of 35 and all the rules and events remained the same, then how many different cap colors were present? Cap colors is still the same thing only, because instead of 7 people, it is going to be 9 people. So cap color, it is still the same thing. So I think it is 9, right? So that cap color is still the same, that is not changing. So it is a very logical question. So the first barrier is to identify that in first round double colored two colored pairs will go, then triplets will go, then 4 colored, 5 colored, 6 colored, all these things will keep going in subsequent rounds. Once you identify that logic, only then you will be able to crack this particular set, otherwise we will not be able to set. It's a barrier set, but once you understand the logic, it's a very interesting set to solve. I hope you had a good time learning. Let's wind up the video now.